there are 4 sessions about relation and function. So very carefully revise all the session, and after that if there is any doubt, then comment in our comment box. If you like this video, please subscribe our channel and share with your friends. Welcome back to our channel Angana Study Center. In the previous class we have done up to exercise 2.3, and today we will practice the miscellaneous exercise and do some miscellaneous problem, which will be help to grow your level, and this will help you to compete with others and high score in your board exam or competitive exam. So let's start our class. Just look at the question. Let R be a real function defined as f such that r to r by fx is equal to x plus 10, and sketch the graph. So here fx, that is y equal to x plus 10. Okay, x belong to r, obviously x belong to r. If we put x equal to minus 2, then y equal to 8, x equal to minus 1, y equal to 9, x equal to 0, y equal to 10, x equal to 1, y equal to 11, x equal to 2, y equal to 12. Okay, so by this point we can now draw graph. So this is x dash, y dash, this is y, this is the origin. 1 2 3 4, minus 1 minus 2 minus 3 minus 4. Okay, minus 1 minus 2 minus 3 minus 4 minus 5 minus 6. Here 1 2 3 4 5 6 7 8. Okay, and 9 10 11 12 also. 9 10 11 12, this is y. Okay, so now put the value of this. X equal to minus 2, y equal to 8. So this is minus 2 and y equal to 8. That means here point will be here. Okay, then minus 1 9. So this is will be here. Okay, now this has been done. Now x equal to 0, y equal to 10. So up to here. Okay, now x equal to 1, y equal to 11 here, and x equal to 2, y equal to 12. That means here. If we join this point, we get this type of straight line. Okay, this straight line will intersect this x-axis at minus 10, 0. Okay, so this is the graph of y is equal to x plus 10. Okay, this should be remembered. Here one point should be noted that here the equation fx equal to mx plus c. Here this type of equation is called linear equation. Okay, linear equation. Here just put m equal to 1 and c equal to 10, then fx equal to x plus 10. Okay, so this equation clear. Just look at this question. Here R be the relation from Q to Q defined by R equal to AB such that AB belong to Q and A minus B belong to Z, so that this one A comma A belong to R for all A belong to Q. Second, AB belong to R implies that BA belong to R. Then third question, AB belong to R and BC belong to R implies that AC belong to R. So we first do the question number 1. Here A comma A belong to R implies that, what implies this mean? This means A minus A belong to Z. Okay, so here A minus A equal to implies that 0 belong to Z. Okay, so 0 definitely belongs to Z. So this condition must be followed. So A comma A belong to R for all A belong to Q. Okay. Now question number second. AB belong to R implies that BA belong to R. We have seen from the definition from the relation R, if AB belong to R, it implies that A minus B belong to R. A minus B belong to Z. That means if A minus B belong to Z, this implies that B minus A belong to Z. This implies that if B minus A belong to Z, from this relation we can write B minus A belong to R. Okay, so we proved that. Okay, now question number 3. AB belong to R and BC belong to R. That means if AB belong to R implies that A minus B belong to Z and BC belong to R implies that B minus C belong to Z. Okay, let this is 1 and this is 2. Now if A minus C equal to A minus B minus B minus C. Okay, this is if as A minus B belong to Z and B minus C belong to Z, so A minus C belong to Z, so therefore A comma C belong to R. Okay, proved. So we have proved the 3 questions. Let F is equal to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a linear function. Linear function means fx is equal to mx plus c form. Okay. So from Z to Z, find fx. So let fx equal to mx plus c, as fx is a linear function. Okay. Now taking the point 1, 1 and 0, minus 1. Okay. Now f1, first 1, 1 we can take 1, 1, then equal to 1, y equal to 1. So now put m dot 1 plus c. Okay, so here this is equal to y, that means 1, or m plus c equal to 1, or equation number 1. Okay, then for the point 0, minus 1, if we take, then y is equal to fx equal to mx plus c. Now put this value. Okay, so here x equal to 0, y equal to minus 1, or minus 1 equal to f0 equal to m dot 0 plus c. That means, or minus 1 equal to c. So this is our second equation. Now putting the value of c in 1. Now putting the value of c in equation 1, we get m plus, here the value of c equal to minus 1, minus 1 equal to 1. That means, or m equal to 1 plus 1, that is 2. Okay, so therefore fx equal to mx plus c. Now put the value of m and c in this equation. Put the value of m and c in this equation. We get fx equal to m equal to 2 dot x plus c equal to minus 1. That means 2x minus 1. This is your answer. Now look at this question. Find the domain of the function fx equal to x square plus 3x plus 5 by x square minus 5x plus 4. we have previously learned that this is the rational function. Rational function means this part will not be 0 if fx by gx is a rational function, then gx not equal to 0. That means we first do this equation by factor. Now x square minus 5x plus 4 equal to x square minus 4x minus x plus 4 equal to x minus 4 minus 1 x minus 4. That means x minus 4 into x minus 1. Okay, so fx equal to x square plus 3x plus 5 by x minus 4 into x minus 1. We have gx mean this part not equal to 0. If x not equal to 4 or x not equal to 1, then x minus 4 into x minus 1 not equal to 0. So we know the domain, x is the part of the domain. So the domain of this function will be, this is the rational function, that means this is a real function. So domain will be the real number except x equal to 4 and 1. Okay, so the domain will be r minus 1 comma 4. Okay, this type of problem may be solved in this way. Okay, now look at this question. The function f is defined by fx equal to 1 minus x when x less than 0 equal to 1 when x equal to 0 and fx is equal to 1 plus x when x greater than 0. So now to solve this and then say draw the graph. So we have to draw the graph. Firstly, since fx equal to 1 minus x when x less than 0. So now put the value of x less than 0. Now x equal to minus 4. Then f minus 4 equal to 1 plus 4 equal to 5. Okay, that means y equal to 5. X equal to minus 3. Y equal to f minus 3 equal to 4. Okay, x equal to minus 2. Y equal to f minus 2. That means 3. X equal to minus 1. That means y equal to f minus 1. That means 2. X equal to 0. We get y is equal to f0 equal to 1. And now we get this when we see this fx equal to 1 when x equal to 0. We get this. And when fx is equal to 1 plus x when x greater than 0. So now put the value of x greater than 0. So now x equal to 1. Then f1 is equal to 1 plus 1. That means 2. That means this is y. And x equal to 2. f2 equal to 3. That means y. X equal to 3. f3 equal to 4. That means y. X equal to 4. That means f4. That means 5 equal to y. So now by this value we are going to draw the graph. Okay, this is x, this is x dash, this is y, and this is y dash. Now 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay. Now putting this value, we first do x equal to 1, y equal to 2. X equal to 1, y equal to 2. That means this point. Okay. Now x equal to minus 1, y equal to 2. X equal to minus 1, y equal to 2. That means this point. X equal to 2, y equal to 3. X equal to 2, y equal to 3. Okay, this point. X equal to minus 2, y equal to 3. Minus 2, y equal to 3. This point. Okay. X equal to 3, y equal to 4. X equal to 3, y equal to 4. That means this point. X equal to minus 3 y equal to 4, x equal to minus 3 y equal to 4, this point, and lastly x equal to 4 y equal to 5, x equal to 4 y equal to 5, this point, and x equal to minus 4 y equal to 5, x equal to minus 4 y equal to 5, this means this point. When x equal to 0 y equal to 1, that means this point, 1 point. So if we join these points, we get this type of graph. Okay, so this should be remembered. Now there are some miscellaneous problem we have to solve. Okay, so this is very, very important. Okay, we have two relations, fx and gx. Okay, then so that f is a function and g is not a function. So now we will calculate this value. Here fx equal to x square when 0 less than equal to x less than equal to 3. That means the value of x from 0 to 3. Okay, so now put this value. Putting this value in this equation, here fx means y equal to fx equal to x square we have. Now putting the value of x equal to 0 when x equal to 0 y equal to f0, that means 0. When x equal to 1 y mean f1 equal to 1, x equal to 2 y equal to f2, that means 4, x equal to 3 y equal to f3, that means 9. And there is another equation. Now fx equal to 3x where 3 less than equal to x less than equal to 10. That means the value of x from 3 to 10. So now putting this value, x equal to 3 y equal to f3, that means 9. So this value is equal to this value, there is no problem. Now x equal to 4 y equal to f4 equal to 12, x equal to 5 y equal to f5 equal to 15, x equal to 6 y equal to f6, that means 18, x equal to 7 y equal to f7, that means 21. Okay, x equal to 8 y equal to f8, 24, x equal to 9 y equal to f9, that means 27, x equal to 10 y equal to f10, that means 30. So just look here, all the element x 0 1 2 3 4 5 6 7 8 9 10 have unique images. Okay, so all the first element in A has a unique image. So f is a function. Now we are going to look this function. Here gx equal to x square when 0 less than equal to x less than equal to 2. So when x equal to 0 y equal to g0 equal to 0, x equal to 1 y equal to g1, that means 1, x equal to 2 y equal to g2, that means 4. Okay, now we have this equation, gx equal to 3x when 2 less than equal to x less than equal to 10. Now put this value, we can get x equal to 2 y equal to g2 equal to 3.2, that means 6. But here just look, when x equal to 2 y equal to 6, when x equal to 2 y equal to 4, that means here all the first element don't have unique images. That means here the image of 2 is 4 and here also the image of 2 is 6. So there are two images. So this is not a function. As there is a repetition of first element, so there is more than one images. So this is not a function. Okay. Now look at this question. If fx is equal to x square, find f 1.1 minus f1 divided by 1 minus 1 minus 1. This is your homework. If any difficulties arise, then we will do this. Okay. How to solve this? You have this equation. Okay. So here just put f 1.1 equal to 1.1 whole square. f1 is equal to 1 square. Okay. So these two can be obtained from that. By that you can get the value. Okay. Look at this question 3. This is very important. We have previously done in the miscellaneous example this type of problem we have solved there. Okay. So this is a rational function. We have to factor this equation. Then from this that factor we can find what value should not be taken as x. Then the domain will be r minus that value. Okay. This is also your homework. Now look at this question number 4. This is also very important. Here find the domain and range of the real function defined by fx is equal to root x minus 1. So now first we write this equation, this function fx equal to root x minus 1. This is a real function. So x should be obtained from the set of one real number. So if x equal to 0, then fx equal to root minus 1. This is not real. So x, we cannot take x equal to 0. Okay. So if we take x equal to minus 2, then y is equal to fx equal to 2 minus 1 minus 2 minus 1. Then this will be also complex, not real number. Okay. So we found from 0 to up to minus infinity we cannot take as the value of x. So now put x equal to 1. We get y is equal to fx equal to root 1 minus 1, that is 0. If x equal to 2, we get y is equal to fx equal to root 2 minus 1, that means 1. X equal to 3, we get y is equal to fx equal to root 3 minus 1, that means root 2. Okay. So here we have seen here all the value of x from 1 to up to infinity, can be up to infinity. So the domain will be within third bracket from 1, that means there is in the set 1 should be remain in the set and up to infinity. So closed with first bracket. Okay. This will be the domain. And what will be the range? Range will be the value of y. That means here we see from 0. From the value of y would be from 0 to up to infinity. That means range will be within third bracket 0 comma up to infinity within first bracket. Okay. These two will be the domain and range of the above function. Okay. Now look at this question. Like the previous, this type of question may be arise. Okay. Here we have fx equal to root within mod x minus 1. F is the real function. So the value of x can be obtained from set of the real number. So here just if x equal to minus 2, then y equal to fx equal to mod of minus 2 minus 1, that is mod of minus 3. The value of minus 3 within mod will be converted to the absolute value, that means 3. Now x equal to minus 1. So y equal to fx, that means mod of minus 2, that means 2. So here we find if we put the value of x as a minus, okay, so we get all the positive value of y. If x equal to 0, y equal to mod of minus 1, that means 1. Okay. X equal to 1, that means y equal to 0. Okay. X equal to 2, y equal to 1. Okay. So here we find that the domain will be Domain will be set of all real number. Okay, and range, what will be the range? Here the value of y, all are positive. All are positive. So from 0 to, that means 0, comma, up to infinity within first bracket. And this type of expression of domain is as minus infinity to infinity within first bracket. Okay, or set of all real numbers. Okay, this question, this is also a very important question. If f is equal to x comma x square by 1 plus x square, such that x belong to R, be a function from R to R, determine the range. So we have to find the range only. Here we have, this is the domain, this is the range. Here this is y. So now put the value of, if x equal to 0, so y equal to x square by 1 plus x square, that means 0, 1 plus 0, that means 0. Okay, if x equal to 1, y equal to 1 plus 1 plus 1, that means half. If x equal to 2, that means y equal to 1 plus 4, that means 4 by 1 plus 4, 4 by 5. Okay, and so much. If x equal to minus 1, that means y equal to 1 by 1 plus 1, that means half. X equal to minus 2, y equal to 4 by 1 plus 4, that means 4, 5. And so find that all of the value of y from 0 to up to 1, 0 to less than 1. That means here all of these are fraction or rational number. This should be less than 1. Okay, so we can write the range as from 0, that means within third bracket 0, comma, here up to 1. There are so much elements. So up to 1, that means within this set 1 is not present. So 1 can be written by closing of first bracket. Look at this question. This type of question we have done in the exercise. So this is your homework. Here f and g such that R to R be defined respectively by fx equal to x plus 1 and gx equal to 2x minus 3. So what will be the value of f plus g, f minus g, f by g? So we have done this type of example in the exercise. So this is your homework. Look at this question, question number 8. This is very important. Let R be a real function from n to n defined by R equal to ab such that ab belong to n and a is equal to b square. This equation must be followed. Are these following statement are true, then one a comma a belong to R for all a belong to n, ab belong to R implies that ba belong to R. Third, ab belong to R and bc belong to R implies that ac belong to R. So now look for the first question. Here we have the question, we have R is a function where AB belong to R, A equal to B square. Now if A comma A belong to R, then A is equal to A square. But in reality there is no possibility of A is equal to A square. But in reality A not equal to A square. So A comma A not belong to R. Okay. So this statement is false. Okay. Question number 1 solved. Question number 2. Here AB belong to R implies that BA belong to R. If AB belong to R, that means A is equal to B square. Okay. When BA belong to R, that means B is equal to A square. This is equation number 1. This is 2. Here A is equal to B square. Here A equal to root B or A equal to root B. So the value of A are not equal as root B not equal to B square. So BA not belong to R. Okay, so this is also false statement. Okay. Now question number 3. Here says that AB belong to R and BC belong to R. So AB belong to R and BC belong to R. That means, so A is equal to B square and B equal to C square. We get from these two. Okay. So this is 1 and this is 2. Now putting the value of B in 1. So we get A equal to B mean C square whole square. That means A equal to C to the power 4. Okay. So from this we can write A comma C square belong to R. Okay. Belong to R. So if AC belong to R, then we write A equal to C square. But here A equal to C to the power 4. As C square not equal to C to the power 4. So AC not belong to R. So this is also a false statement. Okay, this question. F equal to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. Be a function from Z to Z defined by fx equal to x plus b for some integer ab. Determine a and b. Okay. So we have fx equal to ax plus b. Fx means y. Okay. So now taking this value, taking the point 1, 1, we get y equal to, here in this point the value of x is 1 and value of y is 1. So we can write in this equation number 1, we can write this as 1 equal to a dot 1 plus b. So we get a plus b equal to 1. This is equation number 2. Now we get this point, taking the point 0, minus 1 and put the value in equation 1. We get what will get here y equal to minus 1 equal to x equal to 0. So a dot 0 plus b or b equal to minus 1. So now put the value of b in 2. Now put the value of b in equation 2. We get what we will get, a minus 1 equal to 1 or a equal to 2. So a equal to 2 and b equal to minus 1. Okay. Look at this question. Here a, b are given two sets and f equal to this is. Are these following true? F is a relation from a to b and second is f is a function from a to b. So we now looking for the question number 1. Here just look, the elements of f are in ordered pair. Okay, and the first element are taken from here 1, 2 is the element of a, 3 also element of a, 4 also element of, 2 also element of, and the second element are taken from b. So by the definition of relation we can show that f is a relation. Now for the second we have to find all the first element have a unique image in second element. So let's just look, first element 1, 2, 3, 4 and 2 is repeated, 2. So here the image of 2 is 9, here also image of 2 is 11. So this cannot be a function. In F 2 has been repeated. So the image of 2 is not unique. Therefore, f is not a function. Clear? Just look at this question. Let f is a subset of z cross z. That means Cartesian product of z and z. Defined by f is equal to ab comma a plus b. ab belong to z. Is f is a function from z to z? Justify your answer. Now look. Here f equal to ab comma a plus b. Say that a comma b belong to z. That means ab are integer. So now put if a equal to 0, a equal to 0, b equal to 0. Okay. A equal to 0, b equal to 0. We get this is equal to, this is the x, this is the y, then x equal to 0 and y equal to also 0. If a equal to 0, b equal to 1. Okay, then x equal to 0 and y equal to 1. Okay, if a equal to 1, b equal to 1, then x equal to 1 and b equal to 2, y equal to 2. So just look, if we can choose a function by these values, here x 0 and 1 and dot dot, and here we get 0, 1 and 2 and so much. Now look, the value of x, that means 0. 0 has 2 images. That means 0 to 0, 1 image, and 0 to 1. Okay, and 1 has 2. So 0 is repeated, and it has more than 1 image. So as 0 is repeated and there is no unique image of 0. So f is not a function. Clear? Now look at this question. This is also very, very important. Here the set has been given a and f, say that a to n. Okay, be defined by fn equal to the highest prime factor of n. Highest prime factor. So find the range of the function f. Now we first factor this element. If we factor this, 3 equal to 9 and 3 equal to 1. So we get the prime factor is, highest prime factor is 3. From 10 we get 5, 2, 2, 1. So here prime factor equal to 5, and for 11 we get prime factor is 11, and 12 equal to 2, 6, 2, 3, 3, 1, and prime factor is 3, and for 13 we get 13 as prime factor, highest prime factor, highest prime factor, highest prime factor. Okay, so here fn equal to we get y, fn equal to y, we get all the highest prime factor. Okay, so y is the range, so the range will be 3, 5, 11, 13. Okay, that's all for today's class. There are 4 sessions about relation and function. So very carefully revise all the session, and after that if there is any doubt, then comment in our comment box. If you like this video, please subscribe our channel and share with your friends. Thanks for watching our video.